So good morning. Thank you, David, for the introduction. This is the presentation on Open CAPIF SDG, a common framework for API exposure and consumption. It is evident that we are actually in the era of APIs. We have heard in this series of presentations during this conference many times about API definition, API consumption, API development, etc. At the management and orchestration, OpenSlice, Nefio, also from 5G MAG, of course from 3GPP, the northbound APIs, and from ORAN as well in the radio access domain, the exposure of APIs. So it is irrefutably here a need for an API manager or a kind of facilitation of the interaction between the API providers and the API consumers. This need for a kind of standardized or commonly accepted API framework was early identified by 3GPP back to release 14 under the term CAPIF or Common API Framework. So there are three main documents: technical specifications that describe the architecture, the description of the API services that this framework will provide, and also the security aspects around the CAPIF. The key message here is that the descriptions of this API framework are quite generic. This means that the framework itself can be used outside the 3GPP northbound APIs in different concepts. And I have some slides later to see that actually the implementation that we have done of CAPIF has been used in different concepts as well. So it is, as I said, generic enough and can be moved beyond the 3GPP northbound APIs. This is a very simplified view of the functionality that CAPIF framework provides. The heart of this architecture is the CAPIF core function. CAPIF core function is actually the API manager that I mentioned previously. An API provider and API invoker are onboarded to this core function. Then the API provider can publish the APIs, the service APIs that wants to provide to the invoker. And an invoker then can discover those APIs, and after resolving the security aspects, authentication and authorization, the service APIs can be used by the API invoker. There are additional features in the core function, the events that can notify, inform the API invoker, for example, for a new API that is available. And of course, log and auditing services that are very useful. For example, I see here OpenR interface that they have somehow take advantage of those APIs to go towards charging of the APIs provided by a provider. So all the green lines and the boxes here are standardized, so interoperability is achieved. Also, we solve with this API manager actually the discoverability problem, and of course all the security aspects are also resolved here. Now, there was no implementation of CAPIF since the first definition in release 14 by 3GPP, and Fogus Innovations and Telefonica, we actually, in the concept of a research project, Evolve 5G, we decided that it will be very useful to have an implementation of this API manager, mainly because in that project we wanted to expose 3GPP APIs to third parties in order to develop network applications. So within this project, at let's say late 2022, we had a very concrete implementation of the CAPIF based on release 16 back then, and then we decided that we have to move forward and we need a platform in order to maintain, let's say, the code and evolve the code beyond the project lifetime. So we approached ETSI and we submitted proposal for an SDG, and it was approved late 2023, and we started our journey January this year with the kickoff of Open CAPIF. Now our last, let's say, release in terms of development and implementation is the one that we announced in July 2024, which is actually the first release of Open CAPIF, and it is compliant with Release 17 from 3GPP. Now, I will not go deep to the details of the implementation itself. Later today in the afternoon, we have the Hackfest, the hands-on experience on CAPIF, deployment of the core function, and also use of the core function for developing API invokers and providers. What I have to say is that the development, it's a cloud-native implementation. We complement the implementation itself with some test scenarios, which is very important for us to validate that we have done that. What we have done, it is actually fully aligned with what is described in the standard. A second important thing is that we provide API invokers and providers as examples, templates ready to use, so someone can take this code and start preparing its own API provider, own invoker. And of course, there are different software tools that have been used in order to realize all the functionality of the CAPIF core function. Now, the ongoing development work, we actually work on three main pillars. The first one is the alignment with what is now described in Release 18. The target is to have the new release, Release 2, that will be fully compliant or aligned with Release 18. The second pillar is about the enhancement of the current code. There is always room for enhancing the scripts, the deployment process, or providing SDKs to facilitate third parties and externals to use the implementation. And of course, creation of tests and auxiliary components, as I said previously, ready to use providers and invokers for third parties. The Release 2 is expected early January 2025, and we are quite confident that it will be ready and fully aligned with what is described in Release 18. I will mention only two aspects that are new in Release 18 compared to Release 17. The first one is the resource owner-aware northbound API access. So far we had an implementation where the API provider provides kind of resources, information coming from the network or any other concepts that we assume that the API provider can consume those APIs, can use those resources as it has has been provided, let's say, with from the owner of the resources with the ability to use this information. This was a gap, let's say, in Release 17. I will give an example here to better understand the concept. Imagine that the API invoker is an NEF function of the core network, and the resources that are exposed is actually the location of a UE. We need the UE to authorize the use of this location from an API invoker, from a third party. So an additional entity is introduced in this architecture, the resource owner client, and of course the related reference point CAPIF8 here. An additional thing is that the CAPIF core function is not a central entity from where all the interactions are made. We can have multiple CAPIF core functions, multiple instances. So there is also the CAPIF to CAPIF interconnection as a new reference point here in our pipeline to be implemented. And of course, the CAPIF core function can be inside the trusted domain or outside trusted domain, so different reference points are defined. Now, in addition to the development, we built an ecosystem around CAPIF. The first thing is that we want somehow to close the loop with the technical specification and the standardization body. So we started by reading the standards and implementing them, but now we have an experience. We have some lessons learned from the implementation, and we go back to the standards and provide some inputs and some guidelines based on our experience. The second dimension in this ecosystem building is the establishment of synergies, both inside the SDGs, the 4 SDGs that we have with in ETSI, and of course ETSI MEC. I will highlight more this interaction with ETSI MEC later. And as I said previously, the CAPIF implementation started and emerged from a research project. So we want to engage research projects in providing their contributions to the development and also use the CAPIF implementation in their concepts. So for closing the loop with the technical specifications, we managed in this first 11 months of Open CAPIF SDG to feedback our experience, let's say, to technical report 23946 in release 19, with 8 specific contributions this year in 2 different meetings in Maastricht in India. And actually, we're very happy that those guidelines that we have provided have been accepted. So somehow with this, we managed to, as I said, close the loop with the standards. And some of them are in collaboration with ETSI MEC and are related to extensibility features that are described in CAPIF core function. A few more things about the synergies with ETSI MEC. Already documents of MEC describe CAPIF as a potential candidate, let's say, for realizing their architecture. There is a kind of mapping between the registry and CAPIF core function, the MEC apps as CAPIF invokers and MEC services as CAPIF providers. We have started, let's say, a collaboration among the ETSI MEC and Open CAPIF by inviting representatives in our plenary meetings and have more active discussions. And we had already a first webinar, the CAPIF from Standards to Practice, including also 3GPP representatives, MEC representatives, and Open CAPIF. It happened late April this year, one of the key achievements, let's say, of Open CAPIF in this journey. Regarding the engagement with research projects, I mentioned here 7 projects from SNS Call 1 and Call 2. They are the ones that mention in their description of function that they will use in different concepts CAPIF. 60 Sandbox is the one that now provides the major contribution to the evolution of the implementation. From this list, we actually do not include other projects that I have seen in the demo session. For example, the Aeros project, which is outside the SNS framework, but it's also a project that uses CAPIF. And of course, there are Call 3 projects from SNS that starting in January, and we have also some of them that will include and contribute to CAPIF. There is a very simple process to approach us and see what each project does in terms of use of CAPIF or expanding of CAPIF implementation. So by sending an email to SDG support ETSI with a very simple form, we contact and see how you can be part of our ecosystem. We also work on public instance of CAPIF core functions. This will be very useful for someone that wants to use it as a playground for the development and use of CAPIF invokers and providers. And we are establishing an internal process in the ETSI lab to track the contributions from the different projects. So to be aware which project has contributed what in the development. Something very positive, a very positive sign for us is that we have adoption of the implementation from specific, let's say, solutions or products. We have two demos in this conference, the one from Open Air Interface, that they have actually integrated OpenCAPIF in their solution, and a very interesting integration from Emergent. They have exposed SEAL APIs through CAPIF in their mission-critical services. And it is also a very interesting demo that you can see outstairs. Now, I will conclude with this figure. This is the figure that we have seen many times in this conference. It is actually the figure that puts together the work that is being done in Camara, in TM Forum, in GSMA, Open Gateway, etc. Allow me to simplify a bit this. We have actually two main components that are related to the exposure of the technology-specific APIs. The one is the network and compute infrastructure here. So we have 3GPP APIs, ORAN APIs exposed here, and also we have the operation, administration, and management APIs, mainly those specified in TM Forum. Then there is this transformation functions. Those transformation functions will provide the Camara APIs towards third parties. So if we keep these big boxes, let's say, in a simplified figure, I would like to add here the work that is being done by the three SDGs, ETSI SDGs, the OpenSlice, TerraFlow, and of course OpenCAPIF. We see that the OpenSlice is actually working around this operation, administration, and management platform. TerraFlow SDN is more on the transport network, so it is more integral part of the network and compute infrastructure. And CAPIF can play the initial role of exposing northbound APIs, technology-specific APIs. So here, the transformation function is the invoker for the OpenCAPIF architecture, or it can be somehow the exposure, the API manager for the Camara APIs that are exposed to third parties. So the transformation functions are actually the API invokers for the CAPIF architecture.